Okay, so let's look at part B. Part B says using correct units, explain the meaning of the definite integral from 0 to 40 of the absolute value of v of t dt in the context of the problem. So let's do that part first. Let's explain what that means. Well, if you integrate velocity, you are accumulating, you're finding your either displacement or your total distance traveled. How do we determine the difference between the two? The absolute value. When there's the absolute value, we are talking about the total distance traveled. So you need to say that the integral from 0 to 40 of the absolute value of v of t dt represents the total distance traveled by Johanna between times 0 to 40. And it can't hurt to put units in there. I didn't say anything about units. Let's see here. V of t is measured in meters per minute. So we'll say traveled in meters. Okay. So that's part B. Let's see here. Part C, they give you a velocity function. They ask you for the acceleration at time 5. Take the derivative, plug in 5. That's all you're doing there for part C. Let's look at part D. Based on the model B from part C, find Bob's average velocity during the interval from 0 to 10. So keyword being average. So remember that is 1 over b minus a times the integral from a to b of the function in question. Okay, now this is an inactive question, so we are going to have to integrate this by hand, but it's a simple polynomial function, so it's not too terribly bad. The antiderivative would be t to the 4th over 4 minus 2t cubed plus 300t, evaluated from 0 to 10. And then we plug in the numbers. 10 to the 4th is 10,000 over 4 minus 2 times 10 cubed is 1,000 plus 300 times 10 is 3,000. When we plug in 0, of course we get 0 for everything. 10,000 divided by 4 would be, what, 2,500? And then negative 2,000 plus 3,000 is 1,000. So we've got 1/10 of 3,500, so that's 350. You always want to put units. We're talking about velocity. So they told us in part C that it is measured in meters per minute. Make sure you put your units on there. So just make sure when you see that word average, you're always thinking 1 over b minus a times the integral from a to b of v of t. Now, think about it this way though. It's the same thing going through this process of anti-differentiating. Essentially what we're doing is we are finding s of 10 minus s of 0 and dividing it by 10 minus 0. That's what we're doing. The 10 minus 0 is the 1 over b minus a. The integral of velocity is position, and we're plugging in 10, we're plugging in 0 to our position. So There are two ways to go about getting this. It really just depends on what information you're given. If they ask you for average velocity and you have the velocity function, then you're integrating. If they ask you about average velocity and they give you position, then this is what you're doing right here. S of 10 minus S of 0 over 10 minus 0. But it's exactly the same process. It's just, it depends on what information you're given to begin with. Okay? All right. Any questions about 5, B, and D? Okay, let's look at number 6. I'm only going to do one part on number 6 because I think we've got the first 3 parts pretty down pat. Is the speed increasing or decreasing? What do we have to do? We got to compare the signs of velocity and acceleration. Okay, speed increasing or decreasing, compare the signs of velocity and acceleration at 5.5. It's calculator active, so you're just plugging them in. If they're the same, it's increasing. They're opposite, it's decreasing. So that's part A. Part B, find the average velocity. We just did that in number 5. You're going to do 1 over 6 minus 0 times the interval from 0 to 6 of velocity. Let your calculator do the work. Part C, find the total distance traveled. The integral of the absolute value of velocity. Let your calculator do the work. Just make sure that you set it up on your paper. Okay, let's do look at part D. Between times 0 and 6, the particle changes directions exactly once. Find the position of the particle at that time. So how do we find when the particle changes direction? Where velocity equals 0. So you need to write that on your paper, and then it's calculator active, so you go to your calculator, and you either, I would not use the solve feature, okay? I would not use the solve feature here because, remember, it gets bogged down when you have trig / exponentials, nevertheless, when you combine trig and exponentials. So don't use the solve feature, use the graph feature. Okay, plug velocity into y1, change your window from 0 to 6, find where it crosses the x-axis using the 0 function. Okay, so this happens when t equals 5.19552. You never round in the middle of the problem, so you would store that in your calculator. Let a equal, and I'm pretty sure what you can do is after you find the 0, you should be able to copy and paste that value. Copy is under the F1 menu there. You can copy and paste that. So there's the first part. Find the position of the particle at that time. So the position at that time, so I'm just going to say S of A instead of writing out that big long decimal number, is equal to, I didn't read the question stem when we were doing it, but you always have an initial position. They told us that X of 0 is equal to 2, so technically I should be using X instead of S, because they used X for the position function. X of A is equal to, the initial position was 2, the time was 0, to whatever our A value is, of V of t dt. You don't need to write it here because you're just going to put it in your calculator and let your calculator do the crunching of the numbers, and you get 14.134 or 14.135 if you rounded it. They will accept either answer. No, you don't. It just says, they tell you that it changes direction exactly once, so you just have to find where that happens. No, it doesn't say anything about explaining. Oh, A, I'm sorry. A, yeah, you just need to say it, yeah. Yeah. Okay, any other questions about 6 there? All right, let's look at number 7, another inactive question here. We've got another table, and on the table problems, they like to ask you to estimate or approximate acceleration. So again, that's just finding the two values that sandwich. In this case, they want acceleration at time 5, so use 0 and 10. And V of t represents, or V of t is the velocity. V of t is the position. V of t is your velocity. So 2.3 minus 2.0 over 10 would estimate the velocity there. Or excuse me, approximate the acceleration using velocity. All right, part B was just like we did in the other problem there. Interpret the meaning of the integral of the absolute value, total distance traveled, every single time. Approximate it with a left Riemann sum indicated. Did I do that part on the other problem? I don't think I did. I think I just, yeah, I just explained it. I forgot to approximate value. Let's do the approximating part on this one. This one wants a left Riemann sum. So we are approximating velocity. So we start with the value on the left. So the value on the left is 2.0. So we would say the integral from 0 to 60 of the absolute value of V of t dt is approximately, you've got 2 times the width of that interval is 10. Plus 2.3 times the width of the next interval is 30, plus 2.5 times the next interval is 20. You do not use that final number because we were using a left Riemann sum. If we were doing a right Riemann sum, we would start with the 4.6. We would use the 4.6, the 2.5, and the 2.3. We would not use the 2.0. So we've got 20 plus 69 plus 50. So 70 plus 69 is 139. And our units were meters. Okay, part C. Between time 40 and time 60, must there be a time t when Ben's velocity is 2 meters per second? So first thing that I think when I see a question stem like that, I'm thinking intermediate value theorem is the first thing that I'm thinking, because I do have velocity values on my table. So if I look between 40 and 60, at 40 my velocity is 2.5, at 60 the velocity is 4.6. Is 2 in between that? No. So IVT is not going to work for us here. Our other option is MVT, mean value theorem. Okay, mean value theorem. So remember what the mean value theorem says. It says f prime of C is equal to f of B minus f of A over B minus A. So let's put that in context here. F prime is the velocity. F would be position. So they use B, a big B, for position. So we go to our table. And we're going to say, all right, so B of 60 is 49, B of 40 is 9, and that's over 60 minus 40. So that's 40 over 20, which is equal to 2. So there are several different ways that we can phrase this. Let's see here. It does tell us that it's a twice differentiable function. So since B of t is continuous and differentiable. And B of 60 minus B of 40 over 60 minus 40 equals 2 by the mean value theorem. The velocity must equal 2 meters per second sometime between t equals 40 and t equals 60. If you look at the rubric, they phrase it slightly differently, but what you gotta have is you gotta show the work for the mean value theorem, and you gotta mention the mean value theorem, and then state your conclusion. So when they're asking you, must there be a time when some function equals something, first of all, think intermediate value theorem. Am I looking at some representation of that function? And do I sandwich that value? We actually do have the representation of that function here, but it doesn't sandwich it, so that's not what we need to think. Then we go to mean value theorem. All right, last part there. This one's a little different. I haven't seen a whole lot of questions like this, but it is a part, so let's go over it. A light is directly above the western end of the track. Ben rides so that at time t, the distance L of t between Ben and the light satisfies that kind of weird looking function there. At what rate is the distance between Ben and the light changing at time equals 40? So anytime a rate is mentioned, what should we think? Rate in calculus equals derivative. We need to take the derivative of that function right there. So taking the derivative of that function is going to require the chain rule. Bring down the exponent. So you have 2 times L of t. This is with respect to time, so we have to multiply it by L prime of t. Whoops, extra parentheses there. Is equal to 12 squared is a constant, so the derivative of a constant is 0. B of t squared, same rule. Bring down the exponent, keep the b of t the same, times the derivative of b of t. They want to know at time 40, so let's plug in some specifics here. 2 times L of 40 times L prime of 40 is equal to 2 times B of 40 times B prime of 40. So let's see here. L of 40, we don't have that. We'll come back to that part. L prime of 40 is what we're looking for. At what rate is the distance changing? L of t represents the distance between Ben and the light, so L prime is the rate at which it's changing. So this is what we're looking for right there. We're going to leave that. That must mean that we can find everything else. B of 40 comes from the table. B of 40 is 9. B prime of 40 also comes from the table. B represents his position, so B prime is his velocity at time 40, so that's 2.5. So 2 times 9 times 2.5. Okay. Now, L of 40, that comes from that original equation that they gave us. So let's go over here to this side and figure that out. L of t squared, so L of 40 squared, that's what we're looking for, so we leave it, is equal to 144 plus b of 40 squared. B of 40 squared is, or excuse me, b of 40 is 9, so when you square that, it's 81. Oh, that's close. Okay. So if we're solving for L of 40, we take the square root. Let's add 144 and 81, 225. Okay, 220, is that 4? Is it 15? Okay. L of 40 is 15. Did you check it? Now, since this is calculator inactive, obviously you would have had to do a little bit of work to come up with that number. Now's a good moment to remind you that technically you don't have to simplify things. You could leave the square root of 225. You could transfer that over in your problem. Technically, you don't have to simplify it. Let's talk about something else that's going to make life a little bit easier for these computations here without a calculator. When we look at our equation, we've got 3 things multiplied on one side of the equation, 3 things multiplied on the other side, and both of them are times 2. We really don't need that times 2. If we divide both sides by 2, both of those are going to cancel out. So if we solve for L prime of 40, 9 times 2.5 would be 22.5 over 15, which apparently simplifies to 3 over 2. I would leave it like that, honestly. And make sure that you put units. We're talking about the change in distance over time. Our distance is measured in meters and our time is measured in seconds. So put your meters per seconds there. Okay, so like I said, on the rubric they have 3 over 2, but technically you do not have to simplify. Do not lose a point trying to simplify something a little bit more complex like that without a calculator, because you do get a point for the final answer. And don't box it in. I just boxed it in for emphasis. Don't box in anything on the test. Okay, so that one's a little different, but good basic principles for thinking that we need to be able to do. All right, last one. Let's look at number 8. Part A, find the average acceleration. There it is again with the table. So find the slope. Okay, find the slope between 2 and 8. Part B, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time between 5 and 8? Yes. Okay. Sai said yes right off the bat. Why did you say yes so confidently? Right. Okay, intermediate value theorem. You're at 40 at time 5, you're negative 120 at time 8. You got to hit negative 100 to get from 40 to negative 120. This is an intermediate value theorem. Okay, what we're looking at is velocity, so first thought should be intermediate value theorem. So just make sure in your explanation you use the terminology intermediate value theorem, and you need to show in some way that your values on each side sandwich that negative 100. So the way that they do it specifically, just so you know how they handle it, they of course mention that B is differentiable, therefore it's continuous. Remember, you have to be continuous to do intermediate value theorem. And they told you that it was continuous in the problem. We didn't read it, but it does say it's a differentiable function. So v is differentiable, therefore continuous. And then they said v of a of 8 equals negative 120, which is less than negative 100, which is less than 40, which is equal to the v of a of 2, or 5. Sorry, I'm paying attention to my interval there. 5 was the other side of the interval. And then they say, therefore, by the intermediate value theorem, there is a time between 5 and 8 that the velocity equals negative 100. Okay. Part C, at time equals 2, train A's position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving an interval that gives the position of train A in meters from the origin station at time 12. So, let's see here. Did they specifically say anything about the position function? I don't see any symbolic representation of position, so I'm just going to use S. So S sub A, they're using these subscripts because in part D they introduce another train, so just go with the subscripts. So the position at time 12 is equal to, the initial position that they gave us was 300, plus the integral from, that was at time 2, here's a case where it's not starting at time 0, this one started at time 2, until the time we're questioning of v sub a of t, dt. So there's the expression that they're asking for. I'm not going to skip it this time. Use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at time 12. So let's go to the table. They want 3 subintervals. So here's 1. Oh wait, no, we're starting at time 2. We're going to start at 2. Here's 1, here's 2, here's 3. And one of the reasons why I caught myself on the 0 thing was because it said 3 subintervals. If I started at 0, I'd have 4. We're starting at time 2, so start at time 2, break it into 3. Okay, so trapezoidal, we seem to be struggling with the trapezoidal a little bit. Okay, so don't lose the 300 in the very front. Okay, plus trapezoidal, all of them are 1/2, so we're just going to put that in front. It's half base 1 plus base 2 times the height. So base 1 and base 2 are actually your y values. So we've got 100 plus 40 times the height is the length of the interval. That first interval is length 3. Plus 40 plus negative 120. The height is the length of that interval. That's also 3. Plus the last one is negative 120 plus negative 150. The height is the length of that interval, which is 4. Now, being as this is an inactive question, if they had all had the same length, if all of these had been 3, then I would have pulled that 3 out to the front just to make my calculations a little bit easier, but they don't all have 3, so I can't do that. I gotta roll with it the way that it is. So let's see here. We've got 140 times 3, so 420. 40 plus negative 120 is negative 80, so negative 240. That's negative 270 times 4. So 8 to negative 1080. So let's see here. Ooh, big numbers. So we've got 300 plus, let's see here, that would be negative 900, so negative 450. 1/2 times negative 900. Yeah, negative 450, so that's negative 150. And you'll always want to write that in a sentence there at the end. So the position of train A at t equals 12 minutes is approximately, because this was an approximation, 150 meters. Now let's think about it. It's negative 150. It was east, and the train, so it was 300 meters east, and it's moving to the east. How was it west? It said that it was moving to the east. Well, since it's negative, technically that does mean that it's west, approximately 150 meters west of origin station. And that's what the rubric says. I'm just trying to put that together with, it says that the train is moving to the east. Well, at time 2, it's moving to the east. It changes at time 8, or sometime between time 5 and time 8, it changes because your velocity becomes negative, so it starts moving to the west. Okay. We're good. All right, last part. A second train, train B, travels north from the origin station. At time t, the velocity of train B is given by that quadratic function. And at time 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time 2. So let's think about this. We've got, let's just draw our little scenario here. At time 2, we know that train A is 300 meters east. So train A is over here. At time 2, train B is 400 meters north. So train B is over here. So the distance between them is that right there. So what do we have? We've got Pythagorean theorem. We've got x, we've got y, we've got z. X squared plus y squared equals z squared. Take the derivative because we want the rate at which it's changing. Remember, we can make life easier. We don't need all those 2's. We know their positions. Train A is 300, train B is 400. What would be the hypotenuse there? 500. 3, 4, 5 triangle. On an inactive question, they're going to use 3, 4, 5 or 5, 12, 13. Okay, they're not going to put some crazy number on you there on an inactive part. Okay, now dx over dt would be what? Its rate at that time. So we're talking about time 2. Train A at time 2 has a velocity of 100. Train train B, which is represented by the y here, we got to find its velocity at time 2. We got to plug it into the function that they give us. V sub b of 2, negative 5 times 2 squared, which is 4, plus 60 times 2, plus 25, so negative 20, what, 125? Yep. And dz over dt, or z prime, whatever you want to do to represent that, is what we're looking for. So we've got 30,000 plus 125 times 4, 10,000? 250, no, 500, yeah, 50,000. 50,000. There we go. So we've got 80,000 divided by 500 is equal to z prime. Cancel those zeros. 800 divided by 5. 5 goes in 80. Well, 5 goes in 8 once. 6. 160. How did I do that? 5 goes in 8 once with 3 left over. So you got 30. 30 divided by 5 is 6. And you got 0. So then you got the 0 left. I mean, I was doing this. I was just doing it in my head. 1, 5, 3, 0, 6, 30. Now, they didn't actually write a sentence with this one, but you could if you wanted to.